Okay, we're rolling. So the chain rule is about taking the derivative of a composite function, one function plugged into another. Okay? How do we do that derivative? We should all know that. And that was, you had some practice on derivatives as well as antiderivatives for your homework. So how do we take the derivative of g of f of x? For instance, tangent of x cubed. That's an example of a function in the form of g of f of x. What's f of x? X cubed. And then g is tangent of x. Tangent of x. And we're plugging x cubed into that. So how do you take the derivative of a composite function like this? Okay, so there's two things we have to do, and you can do either one first. It doesn't matter. So some of you are saying one, some of the other. Okay, so I'll just, for the sake of something, we'll go inside out. So we look at g first, and we do the derivative of g, and what do we do with f? Keep it. So derivative of tangent is secant squared, and we're going to keep the inside as it is, right? And then this is where this is why they call it the chain rule, because we're going to add a link to the chain, right? We're going to chain on the derivative of the interior function, which is 3x squared. So how would we generalize that? If this thing is g of f of x, then what is this? G prime f of x times f prime of x. So being good at undoing the chain rule means you know the chain rule really well. Okay, so undoing the chain rule means understanding the chain rule really well. And so here's just a simple example of that. So we're going to undo it now. So that means we're going to start with something like this. And how do we know that it's undoing the chain rule? We have the product of two things. How do we know that it's undoing the chain rule? This is how we know. Because we've got this composite function, and you look at the interior function, its derivative is over here, is the other factor, right? The derivative of the interior is there, the other factor of the expression that we have. That's your clue that it's undoing the chain rule. So if you have two things multiplied together, and this is not essentially the derivative of what's in there, you're not going to undo the chain rule. Okay? You're not going to undo the chain rule. So it has to be rigged. It has to be really rigged. But many of them are. Many of them are. Okay. And so what are we going to do? Then we're going to recover the original function g of f of x. So what will you focus on in the rate function to recover the amount function? We got two things we can look at. Which one of those things is going to give us, or what should we look at in order to recover the amount function? Should we look at exhibit A? Or should we look at exhibit B if we want to recover g of f of x? It should be very obvious. Exhibit A or exhibit B? A, right? Because this has nothing to do with g. And this is essentially, this is one step away from this. Do you see that? This is super close to our answer. Okay, so we're going to look at that in order to recover the original function. Okay, and then what happens to this? Well, it just get absorbed because when we were taking the derivative, it popped out as a second factor, but going backwards, it's just going to pop back in, right? So what will the approach be? The approach will be, I mean, essentially, what's the difference? What's the distinction between this and this? What will you do to this one to get that? Pretty simple. We'll look at what? Should we look at the interior or the exterior function? Exterior, and do what to it? Antiderivative. And then we're like 90% done. So you're just going to find this, look for the exterior function, and take the antiderivative. And you'll basically almost have the answer. There may be a little mess we have to clean up, okay? So we're going to write the antiderivative of the exterior function, and we're going to leave the interior function as it is. And that's basically it. Is it making sense so far? Okay, and then what we'll do is, then we'll check it. How can we check it? So we're going to take the antiderivative of the exterior. How do we check it? Take the derivative and compare. So we're going to do this first attempt at the antiderivative. We'll take the derivative of that and we'll compare what we started with. And if they're exactly the same, then we've got it. We're done. We've got the antiderivative. If they're off, then we have to make an adjustment to our first attempt. Okay, so here that's the same thing again, just smaller. So we got two things multiplied together. And we want to think of this as g prime of f times f prime of x, the result of a chain rule. And we need to recover the original g of f of x. So the question is, which one? So we know we're going to focus on g prime of f. So we got to figure out which one of these two is g prime of f, exhibit A or exhibit B. Which one? So basically, which one is a composite function, A or B? B. Okay. So here is our g prime of f. We can do a little check. What's the check? The interior function, its derivative needs to be the other factor, or essentially its derivative. So how are we looking here? If we take the derivative of this, do we essentially have that? Yeah. Essentially, I mean, factors don't bother us with integrals and derivatives, right? Factors just come along for the ride. So what we want to make sure is correct is the power right? So if we take the derivative of this, f, do we have the right power? Yes. If x to the fourth, x cubed, okay? And that's what we need. If that x cubed was any other power, it wouldn't be undoing the chain rule, because the derivative of x to the fourth is 4x cubed, okay? So we're ready to look at it. So what's our first attempt? Well, what do we say? We're gonna identify the exterior function and do what with the exterior function? Antiderivative. What are we gonna do with the interior function? Leave it as it is, okay? So here we go. First attempt. We're looking at this. What is the exterior function? To the fifth. What's the antiderivative of something to the fifth? 1/6. What do we do to the interior? Leave it the same. To the sixth. That's our first attempt. We're almost done. This is it. We're almost done. So what do we need to do to that to see if it's right? How can we check it? We're going to take the derivative. Okay? So derivative will be 6 times 1/6 is 1. Times chain rule, right? 4x cubed. Now we compare. If this is exactly what we started with, our first attempt was right, and we're done. Otherwise, we need to make an adjustment. So are they the same? Okay, we got this extra 4 in here. So our second attempt is going to be, what would we need to do to the first attempt so that if we took the derivative of it, the 4 wouldn't be there? You're so smart. Our second attempt is going to be 1/4 times 1/6, 8 plus x to the fourth to the sixth. And then we can simplify that to 1/24. Do we need to check it? Are we pretty confident? Okay, if you're not, check it. Do it again. Do the chain rule again. Make sure you get exactly this, and you will. Okay, did you see what happened? Did you catch it? Anybody have a question? Yeah, please.
I just had like a kind of general question.
Yeah.
So on the homework, it's not like the trig identities.
Yeah.
Are we required to memorize like derivatives and functions? Because like at my high school, I don't think I got a sheet.
Sine, cosine, and tangent. You should know that, like the derivatives of those, like all the inverse ones.
So like only like cosecant, secant.
Well, so actually, I'm going to show you. I posted a list of all the ones you need. In terms of what you should have memorized and what not, I had to look carefully at the list. A lot of them you should have memorized. Okay. So, but I posted a list, and I'm going to pull it out later when I'll put you guys to work. But yes, lots of those. It's gonna save you a lot of time if you just have them at the tips of your fingers. Okay. All right. Other questions on this example? Okay, new one. Okay. Uh-oh, something's different here, right? What's different about this one?
It's division.
Yeah, it's division, right? And the result of chain rule is multiplication. So how do we take care of that? Yeah. So not quotient rule. We're not taking the derivative, but we're just going to rewrite this as a product. We can do it, right? We can rewrite this first as a product, which would be cosine x times what? No. We're just rewriting this. No derivatives or antiderivatives. We're just sine negative 4. Now it looks like it might be undoing the chain rule. Okay? And what does this mean? Sine negative 4th x. Let's write out explicitly what that means. What do we do first? Sine x or to the minus 4? What happens first? Sine x happens first. And then that's going to be easier to deal with there. But know that notation that they use on trig functions, where they use sine negative 4x, which means this. Okay? So, all right, is it undoing the chain rule? So the question is that thing, if this is undoing the chain rule, what would be our focus here? A or B? B, okay, and so is this essentially the derivative of the interior here? Yes. If it is, then we're green light for undoing the chain rule, okay? And so our first attempt is, we look at this, we look at the exterior function, and we do what? Exterior function is to the minus 4, and what are we going to do to that exterior function? Antiderivative, and what do we do with the sign? Keep it. So first attempt, sine, antiderivative of something to the minus 4. Something to the minus 3, and then we need 1/3. Okay, that's our first attempt. Check it with the derivative. We got negative 3 times negative 1/3 sine x to the times cosine x. Is it exactly the same as that? Exactly the same. We're done with the first attempt. We got it. Okay, so many of you learned U substitution. There's some reasons why I prefer this. One reason is when you get good at this, you can do it in a third or a fourth of the time that it takes you to do U substitution. Okay? The second thing is U substitution, you have to learn something totally new. This is just using your knowledge of chain rule. If you know the chain rule really well, you don't have to learn a new procedure. You can just think about the chain rule, working backwards. Okay? So we springboard off what we've already learned, and then if we get good at it, we can do it a lot faster. But for many of you, it will be your security blanket will be those little U's, and you can use those little U's if you want. But I recommend this. Okay. Here we go. Another ratio. First step, write it as product to the okay. Which one is g prime of f? First or second? Yeah, and this could even be a 1. Like that 6 could not even be there if this was 1 over that. Then that's all you would have, right? Okay, so we're going to look at the g, which is, or g prime is to the minus 1. We're going to do antiderivative, which is to the 0. And then we do 1 over 0. And that was kind of weird, to the 0. And then this got really bad. Okay, so what 2 minus 9x to the 0 is just 1. So all the x's go away. And then we get 1 over 0, which does not exist. So it's like warning bells are flying off here. What's going on? Something's wrong. Okay, something's wrong. Why isn't this working? So we're asking what function has its derivative as something to the minus 1 or 1 over. Okay, natural log. So if you forget that and you start doing the power rule like we just did, and you raise the power and you do 1 over 0, so you got plenty of warning here, plenty of warning that something's wrong, and that should click that, oh no, this is natural log because it's to the minus 1. Okay, so warning, Will Robinson, bad. Okay, and so we start again and we say, oh, that's right, if it's something to the minus 1, antiderivative of something to the minus 1 is natural log. Okay, and so you need to have absolute values. So I'll explain it in a second. Okay, so in your first attempt, you could put the 6 in here. Some of you see there's going to be a negative 1/9. You could put that in too. So when you start getting better at it, you can do a better first attempt. Okay, because you're anticipating what's going to happen. Okay, but we'll just make this our first attempt. This is perfectly fine. We'll do our check, derivative, and we'll get 1 over times 9? Negative 9. Okay, so does this match this exactly? No, we got a couple of issues here. We have a negative 9 here that we don't have here, and then we have a 6 that we need that we don't have here. Okay, so we want to not have the negative 9, but we want a 6. So how do I make my second attempt and clean this up? So we need to have the 6, and we don't want the negative 9. So what do? Divide by negative 9.
Professor, I got a question.
Yeah, please.
From your attempt to your derivative, how did you get from there to there? How did you make the natural log to 1 over?
Because that's what the derivative of natural log is. The derivative of natural log is 1 over. That's the rule for natural log. Yeah. Uh-huh. Okay, so this simplifies to negative 2/3 natural log of 2 minus 9x. So this one has kind of had a few different things to clean up, so let's go ahead and check it with the derivative one more time. So we would have the derivative in blue here. Derivative would be negative 2/3 times 1 over 2 minus 9x times negative 9. And then if we take negative 9 times negative 2/3, what does that equal? Positive 6 times 2 minus 9x, or over 2 minus 9x. Check. Same thing. So we need the plus c. Okay, how's it going? Does it make sense? Okay. All right, first step, of course. All right, this one takes a little more creativity. So what do we got? We got, if it's undoing the chain rule, then we have this form here. We have g prime of f times f prime. So we're looking for something in the interior whose derivative is the other factor in the integral. Do you see something like that? What about inverse tangent?
Isn't that the derivative of inverse tangent?
He wants this is the derivative of inverse tangent. This is the derivative of inverse tangent. So then is this our focus, G prime F, or is this our F prime? Is this G prime F or F prime? F prime, right? It's the derivative of this. So now we just got to see how is this G prime F? How is that G prime F? I see F, but I don't see G prime. Ideas? Any ideas? You recognize what's going on here? Yeah.
The main inverse squared.
Okay. So now it's to the. So yeah, you're seeing this as to the what power? No, this.
Oh, that's to the first.
Yeah. So can you see this as just something to the first power? And so then what would, if that's G prime, then what would G be?
Oh.
Leave the inside as it is. Antiderivative would be? No, leave the inside as it is. It's just going to be power rule, right? Tangent inverse to the. We also need. So the G prime was kind of hiding there because it was just like to the first power. And that's, you don't write that. You don't write to the first power. So you have to be able to recognize things like that. Say, oh, it's to the first power. So then antiderivative would be 1/2 that thing squared. Okay, let's give it a check. Derivative. 2 times 1/2 tangent inverse times derivative of the inside, which is 1/1 plus x squared. Is it exactly the same as what we started with? Yes. Done. Okay, so ask if I'm losing you or if I lost you. Please.
My question is, so you know how it's tan to the negative first x, you would write it as tan x to the negative first? My question is, why did
No, it's arctangent. It's inverse tangent. That's not an exponent. That's not an exponent. That means inverse tangent, arctangent.
Oh,
So I wrote that whole thing to the first power. That's my G prime. So I'm doing antiderivative, which means 1/2 that thing squared.
thank you.
I was wondering why you multiplied it by 2 in the check.
In the check,
Yeah.
how do you take the derivative of something squared?
Yeah, you multiply by 2.
Yeah. 2 times that to the first, right? You see it now?
Yeah, I think so.
Yeah, so it's like, cosine x. How would you take the derivative of this?
Multiply by 2.
2 cosine x times cosine. Other questions? Okay, your turn. Okay, like I said, this technique, it shows up the most. It's probably the most important. It's going to show up all semester. It's the first one you look for. So we want to be good at this. Okay. So if you go to docs and assignments, if you got a smartphone or laptop, down at the last thing there, list of derivative rules. And so I'll put them up also, but you can, all the ones you will need for these problems are there. These are derivatives now, okay? So, because we're thinking about antiderivatives as reversing derivatives, okay? So you got the basic ones, you got all your 6 trig, you got your 6 inverse trig, and then you got your general rules. Constant multiple rule, chain rule, product rule, quotient rule. And as you know from Calc 1, and combinations of all thereof. So let me pull that up. Last fall. See if I can get these to fit on the same page. Yeah, I'm not going to be able to get these all to fit so you can see them. Almost.
Basically, you know that sine is the derivative of cosine.
Nice.
So you can just do cosine to the 5th, and then you know you have to divide by 5 since you've got a lot from.
Okay.
And you add a negative so that your final answer is positive.
Because what's the negative for?
Because the derivative of cosine is negative sine.
You see how fast he did that without u substitution? That's cool. So he saw that sine was essentially the derivative of cosine. Yeah, there's a negative sign. We can work that out later, right? But essentially, sine is the derivative of cosine. And so we saw it's cosine to the 4th. So external function to the 4th to the antiderivative is 1/5 to the 5th. And then he did the derivative and the attempt to himself. You know, so he said, oh, when I take the derivative, I'm going to get negative sine, and I don't have a negative, so I'm going to tack on a negative. That's the beauty of this. When you get good at it, you can just write down the answers. Okay, number 2. More challenging. Nicholas is not here. Lucky. Morgan. Where's Morgan? How did number 2 go?
I changed it to this one
Uh-huh.
b squared plus 1
Good.
times b to the 3rd plus b plus 4 in parentheses to the negative 1/2.
I think it's a good start.
I'm sorry.
You're fine. Take your time.
The answer was 2 times parentheses 1/3 b to the 3rd plus 3/2 b squared plus 4b parentheses to the 1/2.
Okay, so you're looking at this and you're saying this is my composite function, and my external function is to the negative 1/2. So the antiderivative is to the what power? If we're doing antiderivative of this, what power should we have there? 1/2. Okay, and then we would need a 2. So that's kind of like that's our first attempt right there. So we'll take the derivative. I'll do the derivative in red so it stands out. So now the derivative of our first attempt would be 1/2 times 2 goes away, and we'll have v cubed plus 3v plus 4 to the, by the chain rule times what, Morgan?
And
3v squared, good, plus 3. So we're going to, there's our chain rule. Derivative, we're going to compare that to the original. Is it exactly the same? What do we need so that it will be exactly the same?
Over 3.
Yeah. See, because we could factor a 3 out of here and get the v squared plus 1 that we have right there, and then we'd have this extra 3. So second attempt. Is? We need a 1/3, right? So it's going to be 1/3. Oh, but then we have the 2 also, so 2/3, right? Plus C. Okay, so if you're still not sure, see the beauty of this is you don't have to get it perfect. If you know your derivatives, you can check and then adjust. So if you're kind of not sure, just go for it. Just write down something you think is close, and then take the derivative. Now you have to know your derivatives, but take the derivative and compare it to what you started with.
Professor,
Yes, please.
when you took the integral,
Uh-huh.
so it became positive 1/2, you brought a 2 up front.
Yeah.
You wouldn't bring a 1/2 up front, or are you doing the reciprocal?
No, it's going to be a 2 because we're thinking there is no 2, but the derivative with a 1/2, so you're going to have 1/2 times this, but there's no 1/2.
Oh, you just put it there to cancel it.
Right, just like if you were doing x to the antiderivative of x to the 5th, what would you do? You would do 1/6 x to the 6. It's the same thing. We got to the 1/2, so we need a 2. Just like here, you need a 1/6 for the 6.
Sounds good.
Questions on number 2? Okay. Logan Gill. Goyle. Gwill, sorry.
So for this one, pretty sure I did part of it wrong.
Okay, we'll just get started.
Basically, start and recognize that it's pretty much just 2 to the t,
Uh-huh.
and then 2t plus 3 to the -1,
Right.
and then that makes it a natural log.
Good, okay. Great start. So we're doing natural log of?
Natural log of 2t plus 3.
Okay, and I got cut off or interrupted last time that we did natural log. Probably interrupted myself, but you need to have absolute value here because the domain of natural log is only positive numbers. You can only put positive numbers into natural log. But here, you can put any real number into this. So the absolute value allows the domain to still be any real number, so that if this ever is negative, then you'd still have a positive value that you're putting in a natural log. So whenever you do a natural log, you need the absolute values around the argument. Okay? So keep going.
And then I did math wrong.
Okay. So we're going to do a derivative, right? Derivative of that. So what would the derivative of that be?
The derivative, that would be 1 over 2t plus 3, and then the derivative of that.
It's
Then you have to do the chain rule, and that would just be 2t.
So what we need is really the derivative of 2 to the t. And you might not remember that. It's going to be 2 to the t, natural log 2. There's your derivative. Now we're ready to adjust. How are we going to adjust the first attempt? Second attempt now. We got to get rid of the L and a 2. Everything looks good except we got this extra L and a 2. So what do we do? Divide by L and a 2. Again, if you're still not sure after the second attempt, take the derivative and compare it, but that's right. Okay, yeah, you had most of it. You did good. Okay, Miley, how did number 4 go? You're next. What's your name? Yeah. Rudy, you're next. All right, Miley. Uh-huh. Yep. Okay. In here. This is to the 1/3. Yeah. So then your antiderivative would be? So you're still doing that. You're still rewriting this? Yeah. Okay. Sure. Okay. Then what? Okay. We need to do antiderivative, right? So antiderivative means we're going to change this to what? No, it's already 1 divided by 3. We need to add 1, right? Power rule? There you go. So that means our coefficient will be? Good. First attempt. There it is. Derivative? Good. Yeah, that's it. Divide by 7. So our second attempt, that's our first. You got it. How'd you do? The rest of you. So we had the 3/4 and 4/3, but then we need another 1/7 because we don't have that 7 in the original. Yeah.
Oh, you just have to evaluate it. Yeah, you put from 0 to 1. So
Oh, right. Okay. Thank you. So then, yeah. So then we have to. We won't take the time to do it. But you got to evaluate it at 1, evaluate it at 0, and subtract. Right. So we'll leave it at the antiderivative for now. Okay, questions on number 4? You good? Okay, sir. Tell me.
Alright, so you know that you can rewrite each of the 1 over x as each of the x is a -1.
Okay, sure. Yeah, that's good.
And you can have that times x to the -2. And you know that the derivative of each of the x to the -1 is the same as that.
Right, good. All right.
So you rewrite that and you'd end up with an extra negative. You have to throw in another one.
Okay, so what's your first attempt?
My first attempt would be e to the x to the -1 times
So what is the exterior function of this, right? So this is g prime. This is our g prime f. What is the exterior function or the g prime of this? Just e. So antiderivative is just e. So that's it. That's your first attempt. Well, yeah, that comes out in the check. So yeah, you're right. So we're going to do the check, the derivative. So that's the first attempt. Derivative is? You're doing good.
you take another like it would just be x e to the x to the -1 minus 1
Times?
e to the -1. Yeah.
Times what? So now we're going to do the derivative of this. That's not the derivative of this.
X to the -2.
Almost.
No, negative x.
Negative x to the -2. Okay, so now we compare them. How do we change the first attempt? And that's what you said before. And now we're going to evaluate that from 1 to 2. So you got to keep all your negatives straight here. This is. Oh wait, no, that's wrong. Sorry. Just x to the minus 1, right?
Yeah.
Sorry. Not that many negatives. Plug in 2. So let's do this one. Negative e to the 1/2 minus negative e to the 1. Oh. Minus negative, right? Plus? Yeah. How'd I do? Okay. Last one. Volunteer. Who's dying to do 6? Tell me your name again. Was it? Evan. All right. What'd you do?
One, you can split it up. 2 parts added on top
Okay.
into 2 fractions. So you have sine over cosine and then secant over cosine.
Okay, this is going to be an important technique that you can recognize that you have this expression, but you're actually going to have to turn it into 2 antiderivatives first. Each individual one you can do.
So you have tangent over 1 over cosine squared, which is the same as tangent plus secant squared x.
What are you doing here?
Change the first part into tangent,
Tangent, okay.
and then the second one would be 1 over cosine,
Okay,
which is 1 over cosine squared,
right? Which is?
secant squared.
So I like that one, but I don't like going to tangent here. Because what's the antiderivative of tangent? Not sure. So we don't want to actually make this into tangent. We want to leave it as it is. And do like that. So change sine over cosine. So this would be how you would take the antiderivative of tangent. You start by doing sine over cosine, and then you can do sine over cosine, or sine times cosine to the minus 1. And how are we going to handle that?
Natural log of cosine.
Natural log of cosine. Are we done? Is that it? I mean, just for this part. You need a negative, right? When you do the derivative of this, you get 1 over cosine times the derivative of cosine, which is negative sine. So we'll need a negative here. Okay? Plus antiderivative of secant squared is just it's just a rule that you know. You should. Secant squared is the derivative of tangent. So if you've got secant squared, antiderivative is tangent. Plus c, done. Okay, so listen up as you quietly pack up. For Wednesday, it's going to be web work on these. Here's the thing with web work. My experience with web work, especially in this course, is that students can somehow magically do really well in their web work and then come into class with really no skill or ability to do those problems if I gave them one. So we're going to have, whenever there's web work, expect a quiz. Expect a quiz on the web work stuff. So yes, you want to get credit for the web work, but you need to learn it, or else you won't succeed in the course. Okay? What's that? No, just on the web work that's due that day. Okay.
Thank you.
Okay, you're welcome.